According to the National Electrical Code, using a 3-pole static transfer switch to serve a 208/120 volts load, where the static switch is connected on each line side to a transformer, presents a code violation if the neutral is not switched at the static switch and the neutrals of the two transformers are bonded together at the static switch. Both transformers being connected to a common grounding electrode system does not negate this violation. NEC Section 702.115 explicitly states that static transfer switches shall be electrically operated and mechanically held. The key implication is that the static switch must be designed and implemented to switch all conductors of the circuit, and this includes the neutral conductor. This requirement ensures that there's complete isolation between the sources when the switch is in transition, thereby preventing potential hazards and ensuring the integrity of the electrical system. Furthermore, bonding the neutrals of the two transformers together at the static switch introduces another code violation. NEC Section 250.28 provides the requirements for bonding and grounding. It mandates that the neutral conductor be connected to the grounding electrode conductor at only one single point. This is typically at the main service panel. The logic here is to prevent multiple ground paths, which can lead to circulating currents and potentially hazardous conditions. In a scenario where you bond the neutrals of the two transformers together at the static switch, you are effectively creating a second path to ground. This second path can result in a ground loop, causing unwanted current flow through the grounding system. These circulating currents can lead to several problems, including but not limited to electromagnetic interference, elevated equipment temperatures, and nuisance tripping of overcurrent protective devices. The correct and code-compliant way to connect a 3-pole static transfer switch to serve a 208/120 volts load involves connecting the static switch on each line side to a transformer, while ensuring that the neutral of both transformers is connected to the grounding electrode conductor only at the main service panel. This single-point connection adheres to NEC requirements and prevents the creation of multiple ground paths. To elaborate further, consider the implications of not switching the neutral in a static transfer switch application. When the static switch transitions from one source to another without switching the neutral, there is a potential for a momentary interruption of the neutral path. This interruption can cause voltage imbalances and can disrupt the operation of sensitive electronic equipment connected to the 208/120 volts load. In addition, a floating neutral can create a hazardous voltage condition, potentially exposing personnel to dangerous electrical shock. The requirement to switch the neutral ensures that a continuous and reliable neutral path is maintained at all times, irrespective of the source being utilized. It's also critical to understand the purpose of grounding and bonding in electrical systems. Grounding provides a low impedance path for fault currents to return to the source, allowing overcurrent protective devices like circuit breakers to quickly trip and clear the fault. Bonding, on the other hand, ensures that all metallic parts of an electrical system are at the same potential, minimizing the risk of electric shock. By adhering to the NEC guidelines for grounding and bonding, you enhance the safety and reliability of the electrical system. In the context of static transfer switches and transformer connections, maintaining a single-point ground and switching the neutral are paramount to preventing ground loops and ensuring continuous neutral integrity. In practical terms, when implementing a static transfer switch with a 208/120 volt system fed by two transformers, a meticulous approach is required to ensure code compliance and system reliability. Firstly, verify that the static transfer switch is rated for switching all conductors, including the neutral. This means the switch should have a 4-pole configuration, where 3 poles are used for the phase conductors and 1 pole is dedicated to the neutral conductor. Secondly, ensure that the neutral conductors from both transformers are connected to a common neutral busbar at the main service panel. This busbar should then be connected to the grounding electrode conductor, which in turn is connected to the grounding electrode system. Thirdly, do not make any additional connections between the neutral conductors of the two transformers at the static transfer switch or at any other point in the system. Maintaining this single-point ground is crucial for preventing ground loops. Fourthly, conduct thorough testing and commissioning of the static transfer switch after installation. This testing should include verifying the proper operation of the switch, checking the voltage and current balance, and confirming the integrity of the grounding system. Furthermore, it is advisable to consult with a qualified electrical engineer or inspector to ensure that the installation complies with all applicable codes and standards. The National Electrical Code is a comprehensive set of guidelines that aims to ensure the safety and proper functioning of electrical systems. Compliance with the NEC is not only a legal requirement in many jurisdictions but also a fundamental aspect of responsible electrical design and installation. Understanding the specific requirements related to static transfer switches, transformer connections, and grounding is essential for electrical professionals and anyone involved in the design, installation, or maintenance of electrical systems. Moreover, ongoing education and training are vital for staying abreast of changes and updates to the NEC. The electrical industry is constantly evolving, with new technologies and practices emerging regularly. By continuing to learn and adapt, electrical professionals can ensure that they are providing the highest level of safety and reliability in their work. In summary, when dealing with static transfer switches and transformer connections in a 208/120 volt system, it is imperative to adhere to the NEC guidelines for switching the neutral and maintaining a single point ground. Failure to do so can result in code violations, ground loops, and potentially hazardous conditions. By following best practices and consulting with qualified professionals, you can ensure the safe and reliable operation of your electrical system.